So I'm going to talk through some testing challenges that I just kind of encountered, and it was a bit of an interesting scenario for me, just based on the types of tests I was trying to write for something. And I'm gonna kind of give you a real concrete example for a situation I was trying to handle in this fun game we're creating, and uh, and sort of the trade-offs that I was making in terms of how I had to structure my tests. So for some context for the actual situation that I'm trying to create in the game is that the character, or like you as the user, I guess, should be able to take items that you have in your character's inventory, and based on the type of item, if they're stackable, you should be able to drag and drop items that are stackable such that the stacks combine. So, as an example, if you had, a stack of 5 coins and another stack of 10 coins, if they're the same coins and there's like stack limitations that are met, you should be able to drag and drop those coins onto each other. So that's the idea that I'm trying to accomplish here. And I already have this system in place for being able to drag and drop items in an inventory and equipment and so on and so forth. Um, so I figured, okay, I'm about to go mess with this to make this stacking logic. So this would be a really good opportunity to start adding some tests in. I hadn't already done this before for this part of the code, so I figured before I get, to changing this behavior, I should definitely go cover this with some tests so I don't break it. And I guess a bit of like hindsight at this point was I don't think I acknowledged up front that some of the code that I'm about to go alter isn't actually designed like as well as I would like. And I'm gonna maybe try to draw that out kind of briefly what I mean. Um, or maybe I'll just kind of point to it in the code. That's probably easier. So I'm gonna jump to the bit of code that we have that's responsible for handling drags and drops. You can see already just by the structure of this, there's lots of of conditional checks for certain things. But I guess the specific things I want to call out are, um, maybe I shouldn't collapse those, but there's a whole bunch of logic in here. Specifically, I'm going to highlight this section here. Out of this section, this really handles if you have two containers of items. Each of these will go run this block of code to handle swapping something in and swapping something out. And that way you can think about, if you drag and drop in an inventory, if you want something to go to the other position, they kind of have to trade places. If you're moving something into an unoccupied slot, technically you're swapping with nothing. That's the idea here. However, this block of code handles the base case, but then there's also, um, like already you can this part is the thing I just added, and this part is some other thing that's a bit unique. And the thing I don't like about this code is that when we're talking about our entity component system framework that we're using, basically I had to go modify this class to have knowledge about some entities and components that you can use for socketing. And socketing is just like being able to take a gem or something and put that into a weapon. Like that's the idea there. And that's through dragging and dropping. So I had to go modify, this, what should be kind of generic sort of item container to account for this new behavior that we're adding into the game. And for me, that feels like a wrong pattern. It should be kind of inverted where I don't have to go break open this class to modify it to extend the behavior. And I knew that I was going to end up doing the same thing for item stacking because it worked well here. However, uh, I'm going to have to find a way to extract these things and kind of invert that, like, who knows about the other kind of thing, so that this class that we're looking at does not have knowledge about these specific things. So anyway, this is something I should have realized before jumping into the test, but it didn't take me too long to kind of figure that out. So I'm going to jump back to the test for this class and show you what I started to write. In this particular case, I was jumping into some unit tests, and unit testing from my perspective is going to be basically focusing on parts of a method that I want to execute. It's going to be a lot of mocking, so you can already see here I have mocks being set up. I use this MOQ framework mock and XUnit basically for all of my C# development. They're just two tools I use together that I'm very familiar with. So in this particular case, I'll kind of explain a little bit about how this unit test is set up. So if you don't have prior knowledge, it might help kind of understand the code we're looking at. But in XUnit, when you label something with a fact, this is the test that's going to be run. So this is an example of a test method labeled by fact so that XUnit can identify this as a test to run. The constructor that we have for our test class, this constructor will run before every single fact that we have in here. So just to quickly show you, there's two facts that you can see. And that means before this test runs, we'll run this constructor, and before this test runs, we'll run this constructor. So I can put common setup code in here and not worry that like this bag item set you see here, this will not be reused between tests. It will actually be recreated, just for full transparency. I use strict mocks when I'm doing what I consider true unit tests, and this is because if something is not set up properly, it doesn't silently just run. It will actually throw an exception and say that you forgot to set this up, because we should be explicit with our unit tests. And then otherwise, we're just kind of creating the mocks. So these are the dependencies that our bag item set is using. So hopefully that's kind of a brief setup for what's going on. And then I'm just going to walk you through this first test that I wanted to create. So something really simple. So when we're swapping, you have to specify what you're swapping out and what you're swapping in. So on this method call here, this is the method that we are testing. And I'm basically saying that this test is going to be handling when this is null, which you can see up top. I should have probably defined it a little closer here, but yeah, this value that we're passing in here is null, and we're actually passing in something, some actual reference as the thing we're swapping in. So if we're swapping out nothing and swapping in something, that's really just adding. That's what this test is for. And then we got a whole bunch of other stuff kind of going on in here. So because this is a unit test, I need to actually mock out the dependencies that we have inside of bag item set to do the right thing. So this is sort of the first initial kind of trade-off with this unit test. And there's a benefit to this and a drawback. The drawback is really like I have to set this up explicitly. I have to know the assumptions about what this is supposed to do when certain things are called. So for example, I know that when this is called on this dependency, if it's doing the right thing, it basically has a contract that it needs to raise an event. But I had to know that. I had to go code that because it's a mocked dependency. But the benefit is like if I didn't set this up, if I didn't set up this whole thing here, like this type of test actually ensures that the code I've written is being executed the way that I expected. So it's it's a pro and a con there, I guess. So I set out to approach it this way. And if we kind of walk through what bag item set does in swap items, I'm just going to jump back to that class now. If we go to the very top here, first thing it's doing, it's trying to find an item to swap out. I don't want to explain the details specific to the game here just because I want this to be more around the test, but basically we need to give it an ID. So this item set will go get us the item for that ID. With a null that we're passing into here, we're going to get a null out. I'm just explaining so I don't have to dive into each part of the code. And it's not going to be equivalent, so we're not going to do this part. We're going to go into this block here. This is really just something that suppresses some background events from firing. So because item to swap out is going to be null, based on everything I've just said, this is going to be the first part of this method that we're exercising that has a dependency, which you can see is highlighted, item container behavior. where we call try add item. So this is why in the test that we were looking at, I have to explicitly set this method up. So hopefully that makes sense. I had to go say, look, we expect to call this, we expect it to have this parameter, and then I'm going to mock out what's happening there. Then if that succeeds, which we control in our test, right? So in the test, I can actually flip the return value around and say, hey, look, what should happen if it doesn't succeed? Like, that's the power of this unit test, is that we can kind of control the flow of the logic in the system that's under test. So in our current example, this is going to return true. So we're going to skip over this exception throwing because it's like a valid pass. And then we're going to invoke this event and return this value. So that's what this test back over here is supposed to do. So we call the test method. It's going to end up getting to this dependency, like I had mentioned. It's going to call try add item, do this callback, because that's what that is supposed to do under the hood. And we should expect on our bag item set that we do get items changed raised. And this is just going to keep track of how many times that happens. So at the end of all of that, we should expect that we get this return value. We should only get one of these events raised. And the other thing we're checking here is that our mock repository, we're just going to make sure that everything we've set up was actually called. So that's the sort of the inverse part to a strict mock. A strict mock will tell you, it will throw exceptions if you didn't set something up. But if you set up too many things, right? So if you have extra setups in your test, this verify all will catch that for you. So anyway, it's a super verbose way for us to just try and add an item. But I set out and kind of did this first test, and then I said, okay, what's going to happen if we do it the kind of the opposite way? So in this next test, if we have an existing ID for an item that we want to swap out and no item that we're swapping in, this is not an addition, this is actually a removal, right? So I'm just trying to cover these two basic cases, and I'm going to quickly show you how I kind of ran into my first kind of hurdle here, and why I decided to switch my mind for going down this route. So this test is going to look very similar, but we're going to have this item that we were, instead of like trying to, in this example, we were swapping it in, we're going to be only swapping it out. But based on the scenario, I'm trying to swap out an item that already exists in our item set. So to make it a little bit more complicated, I have to basically assume that this item is already in the item set before I can pull it out. So already that's a little bit convoluted. I have to kind of do some extra setup here. So in this particular case, you can see that I end up calling this to swap in the item here, and this swap out item is set up here as well. So if we kind of, it's be a little bit more obvious if I kind of just walk through the setups that are going on. So item ID to swap out is being set up. We are assigning that to an item identifier, and it's actually going to be the same one that we're swapping in. So I know that sounds a little confusing, and this is hopefully already a good indicator as to what I was kind of going through initially. Like, this is really, however many lines of code that is, that big block that I'm highlighting is really just to set up this item that I want to move around. Okay, so the idea is that we put the item in first, and then we're going to try pulling it back out. And I only want to start checking events when I go to do the swapping out portion of this. So hopefully that makes sense. I have to set up my container by adding it first, and then I'm about to pull it out. But what was really confusing about that is that because I own these dependencies, I already didn't have to do that. I have full control over them. So I, I already kind of made a misstep here. I didn't have to go add the item first. I can actually set up the dependency such that it knows it's already in there. So that's, you know, like I write unit tests all the time, and I kind of already messed this assumption up. So I'm just kind of showing that's a little bit confusing, if that wasn't obvious yet. But the next part that made it even worse was that I said, okay, I'm going to jump back to this code here. I have to start like an item to swap out. That's not going to be null anymore. That's actually the thing that we're trying to pull out of the container in this case. So we're not going to go into this block of code. Um, this code wasn't here yet, so pretend this is not there because I guess I should leave the other part, sorry. This block of code wasn't there because this is what I was going to add after. I wanted to test that this was working as expected ahead of time. So then I had to start saying, okay, like, because I'm about to access this dependency again, I have to go set up items. And then I realized, oh crap, I have to go make sure that I can handle all of this socketing logic. And in this particular case, I don't want it to execute. So I have to go understand what's in here. I have to go open this method, check it out, make sure that I can cause it to return early, because we're not socketing items in this example. So already you can see that I had to really start understanding all the inner workings of this class so that I could truly drive the sort of the code execution that I wanted it to follow. Now you might be looking at this and saying, well, you should have designed it differently, like this should have been extracted. You're right, it should have. And if I would have pulled this out, this probably would have been a lot more easier to unit test. So, I mean, there's that. But it's not like that yet. And this is why, you know, kind of upon reaching this point and going, I don't know enough about how I kind of want to set this up. Um, it's probably worth that I like kind of skip the unit tests and go right to functional tests, and that way I can actually kind of guarantee the expected behavior we want, and then I can go refactor this. Then I can actually go pull this stuff out, flip it all around, and prove it still works. So if you're still with me, I'm going to go back to these tests here, and I'm actually going to show you not these unit tests. We're going to get rid of those. And I have all of these functional tests. Maybe I'll put them back and then we can compare them, but I'm going to comment them out. Okay, so those are out, and these ones are coming back in. And we're going to look at the difference here, and hopefully you'll see that these are a lot more straightforward to read. And this is, by the way, this is coming from someone, like I love writing true unit tests and mocking things. Like I love doing it, I don't know why. But this is a really good example of where it just didn't make sense. And I'll kind of reflect on that at the end again. So let's go back to, this is essentially a functional version of the first test we wrote. In functional tests, we're not going to be mocking anything out. We're actually going to be using real things from, like real classes that we have set up. So I'll explain what's going on here for our setup because it's a little bit different. I'm using AutoFac for all of our dependency resolution. So we have a container that's going to basically have all of our services and things that are registered that we want. I need a game object factory because this is what's going to make items for us. So I store references to both those things. You'll notice this is static. I only need this stuff to run once for all of the tests in here. But just like the unit tests, I need to make a new bag item set for each test that we want to run. Otherwise, it carries the state between the tests, and we don't want that. So between tests, I need a new one of these. And what you'll notice is that it's truly a real bag item set. It's truly wrapping a real container. And these come off of our container, and they are also real implementations. So that's important here. It's a big difference. The other case for unit tests, these were mocks. These ones are actually what's in the game. So hopefully that kind of is already explaining some major differences here. And because they're real things that are in the game, instead of me having to manually set things up, the trade-off is that I have to, manually set things up in terms of the things I'm mocking. I don't mock, but I have to ensure that any dependencies are in a state where I can use them. And right now we're pretty fortunate in this case where we don't really have others set up. So if we jump into this test again, this is the functional version of the first one we looked at, and you can see I need to give our item an identifier, and we're just calling it the item being swapped. This looks a little verbose just because it's based on some of our other sort of like game architecture, but we haven't gone through and kind of put like a nice clean syntax on stuff, like some extension methods to make it pretty and easier to read and use. So a lot of this is verbose, but anyway, this makes an item that we're going to move around. So it's pretty simple. This is the same type of thing that's going to be checking for events because we're going to count how many of those we fire. And that's it. Like, we actually just try to do the swapping, which, like the first example we talked about, a null to swap out means we're not taking anything out, but we're putting an item in. So this is a test that adds an item to the container. But you'll notice there was no setting up of dependencies. That's gone. We didn't have to do that here. So at the end of this, we can already just start asserting that the right thing happened. So did we get the right return result? Did we get one event, because we only expect one? We're asserting that we're only adding, like there's only one thing in the item set after, and we're asserting that it truly is our item. So hopefully you can see that, there's way less setup code here. In this particular example, we were able to assert all the things we wanted, and overall is very straightforward. The next test was the one that I didn't even complete the first time around. And again, let's have a look at it. Very similar in terms of setup to this test here. Right? We're just creating this item that we're going to be swapping. Like I explained earlier, we want to have the initial state of our test be that this item is already in the item set, because we're going to be testing that we can pull it back out. So we do this as part of the setup now. But look how simple this is, right? There's no dependency setups here. I'm setting up my initial state. So that's going to have to happen in either of these tests, but I didn't have to set up the dependency, which was nice. We're going to be checking for events, and then this is actually exercising the test method. And then we can assert. So overall, like, I didn't have to go set up any of my socketing dependencies. I didn't have to go know about that. And because I'm not explicitly setting up dependencies in either of these tests, I now have the luxury of being able to go refactor the code inside of swap items. I can refactor that and not necessarily worry about these tests, like not compiling or breaking because of the setups. They might break if I break the logic in here, but I'm in a position where if that logic in there breaks, these tests are going to tell me, hey, look, you broke expected functionality. Versus with the unit tests, it's not that you necessarily broke expected functionality, it's that you have the wrong things being set up now inside your unit test. So they basically cover very different things. But quick reflection just on this part in particular was that it made a lot more sense for me to use functional tests because I know already that I want to go refactor this this bag item set class. I know that I need to go refactor it and change the internals of it. Knowing that ahead of time, to me, was a really good reason that I should have started with the functional tests, because the unit tests, I'd have to throw them away if I ended up going to refactor all of that. So hopefully that makes more sense. Going forward, once that's all refactored the way I like it, depending on how separated out things get, I might go add unit tests for some extra validation. And to touch on that, just some quick examples. I think this was a pretty good spot here. unit tests, in my opinion, are nice for this kind of thing, where if I want to make sure that I can kind of force my code execution to try this out, or to try this out, or this, like I can tune my setups to be such that it navigates down these paths. Um, but there's, in my opinion, there's too much code in this class to make a unit test setup that's really helpful for this, because to get, as an example, to get to this part of the code, I have a lot of setup on dependencies to have to get this far, and that kind of sucks. Okay, so I think that's probably all I wanted to say about that. I'm just going to quickly pull this up. Sorry that that's probably pretty bright and flashed in your face, but I actually put this other video together just quickly highlighting unit versus functional tests. I put this together essentially before this video because I thought this would be a really good opportunity to touch on it. But I'll put a link to it, and it's like 2.5 minutes long. So if you made it this far, you can definitely make it through this other one. But it really just kind of touches on maybe some thoughts around when you want a unit test and why you might not. So some cons, and then the same thing for functional tests. So when you're thinking through these different things, it might help you kind of pick and choose when you should be writing a unit or functional test. And I think the other thing to mention that's important is that you should probably have a mix of both. It's not that one of these is better or worse. In my example that I gave today, the the moving of items in between this item set with like adding and removing things, that lent itself really well for functional tests because of this. One sec. Uh, because more resilient to refactoring, right? In my situation, I knew that I was going to have to do this. So that's probably why I should have started with a functional test. So anyway, hopefully that was a good example. I'll try to put some links to the. I think all the code should be on our GitHub too, so I can put some links to the actual code. Hopefully that's helpful if you want to go peek through what that looks like. And otherwise, yeah, hopefully that was beneficial. And thank you for watching.